So actually, after an intensive day yesterday, I was thinking, okay, it might be too hard now to keep the momentum with all the presentation. The topics were raised yesterday, but I will do my best and start talking about the AI hype. Like, we hear about AI every day in the newspaper. AI will replace people. Artificial intelligence is coming in strong. Will we survive? Will AI destroy us? All this kind of myth and noise about AI. And I would like to ask you about your impression when you see such statement every day, changing the world around us, transforming everything, blah, blah, blah. But this giving you a kind of awkward feeling and you'll be suspicious about AI. But may I ask, wasn't the case 30 years ago when we start with automation? If I just replace AI with automation, it will be the same thing. So this is always happening with any new emerging technology. People are suspicious about it because at the early adoption, it will be struggling to adapt this technology. The technology itself, it's not that mature enough, and people will start to be suspicious about it. And it's like every new technology, first adapters win everything. So, but math is the same math. No AI scientist or data scientist came up with a new data mathematical model. Programming is the same concept of programming. So what happened? Why now everyone is talking about AI and as something new and this bubble and the hype around AI? Actually, the only thing they came up with new architecture that merge or leverage this mathematical model with the programming principles in order to bring something new that never happened in the past, like parallelism in the neural network, or the computation power also backed this evolution or revolution. We start see TPU, GPUs, and so. At the end, nothing is new. And that brings me to introduce myself. So me, I am Dr. Moussab Orabi, Vice President Data and AI at Rosenberger. I am actively writing about AI, I think since my first article is already 10 years old or 12 years old. I'm really interested in AI, but in real AI, to be honest. It's AI in industry. How to use AI. How to make things happening in industrial world. Why? Because in industrial environment, it's a robust environment and it's zero tolerance for failures. Yeah, it's not like chatbot, you are chatting with it, it's okay. If it starts hallucinating or giving any randomness response, no. In industrial environment, we are zero tolerated for errors. Good. But this brings us to the history of AI. As I said, it's nothing new. It's almost now 75 years old, AI, since the Turing machine. When a genius Alan Turing thought about how can we teach a machine? Can we mimic the human intelligence? And coined by that, then McCarthy came with the first term of AI. And what is it at the end? Artificial intelligence. Okay, what does that mean? Okay, artificial, smart, being smart, genius. Okay, intelligence. Is it not human things? No, it's a mimicking of the human intelligence. Trying to make a machine or a program to act like a human in certain aspects. But again, this is almost 70 years old now. So nothing, why we are talking about AI. Back to the journey of AI, the first machine that people think about, this super problem-solving machine can solve everything. People start thinking about it in 1960. Chatbots. We are amazed by the ChatGPT, but to your knowledge, the first chatbot was 1960. Elisa. It tried to mimic the diagnostic for doctors. You can ask him, give him the symptoms, and giving you some diagnosing. Autonomous driving. to be surprised, 1995. So Ernst Dickmann managed to make a car driving from Munich to Copenhagen autonomously, alone. So nothing new when we talk about, okay, autonomous driving in Tesla program. No, this is too old. Now it's just backed by the computation power. 2010, the boom of the internet and IoT data and everything around everything started to generate data. 2020, start thinking about smart cities, monitoring every emotion in a city. Yeah. 2025, large language model, GPT-5, Bard, Gemini, and. But at the end, it's really an evolving journey. Nothing new at the basic in the mathematical models or the programming principles. It's just the way how we put these together. That's why there is no need to be afraid of it. But again, as Willem said once, in God we trust. Anyone else need to bring data, need to show evidences on this. Yeah, and that's why this is bring me to tell you about our journey at Rosenberger, AI journey. So we are at Rosenberger. It's time to introduce Rosenberger. It's a manufacturing company, 15,000 employees, more than 600 engineers, and 800 patents. We are specialists in solution connectors, from cable to connectors in high voltage, fiber optics, and radio frequency. And we have a lot of industrial processes: injection, molding, plating, shaping, and welding. Yeah. And different machines, different technology, from full automated machines, semi-automated machines, and sample series production. Good. We start to assess AI, but really to talk about AI and any kind of AI, the bigger umbrella of analytics, we need to think about what's the difference, how to transform my data from being just a data to information and then knowledge out of this information. So again, I think this one, I hope it's working. Nice. This is a good toy. Yeah. Everything started with data. And 30 years ago, the first warehousing system started, data warehousing. I think it's from Oracle. Like, it doesn't matter. I don't like this toy. Yeah. And people started online analytical model and the online cube, but all this, when we are ending with a dashboard in the Power BI and the Tableau as Power BI models, we are talking about, let's see, I think now we are talking about being descriptive, showing what happened in the past. Yeah. So I cannot predict the future. And here came the AI as a predictive model that I know what happened in the future, in the past, and I can predict the future. And there is a good saying said that we can predict the future by projecting the history or the past in the right space. Meaning, if I'm looking at the past, my historical data, I can predict the future, what will happen with the right projection and space, or the projection in the right space. And here came the AI models and these bird vector machines doing the same concept, or machine learning models doing exactly the same, trying to learn this statistical pattern in the data, in your data, and to predict the unseen data, which is the future for them. Giving the predictive models, he starts what will happen in the future, and then optimization action, like respective analytics. Okay, now I know the past, I know the future. What should I do to optimize my processes, optimize my operations? And everyone is aiming for the ultimate goal is autonomous system. Machine running by itself, adapting itself to solve the problem by itself, but this is still a future. And it's a realistic future, to be honest. Everyone should look at himself by looking at this kind of a maturity model. Where are we locating? Are we still a believer? We talk about AI, we talk about this hype, we didn't join this journey yet. We are getting organized to start doing something here, attending conferences and having someone who has interest in doing AI at our organization. Or are we an expert? We are using AI with purpose. We are enablers. We're empowering our business with AI, or we are champions. We are leading the industry with AI. By having that in mind, we start Rosenberger, this kind of assessment, data and AI assessment journey, and then we set up our AI North Star, which is our strategy. And our AI and data strategy should be aligned to our business strategy. So we are manufacturing company. We need to be distinguished from the others, better than them, reducing cost, profitable. Profitability is for us is a goal also, and sustainability. So all this, every company there are different business strategy models, but everyone can put his own strategy and say, okay, my AI strategy should align with my business strategy. And from that, we defined our North Star, what should we achieve, and then this achievement will be driven by the actions, which are the use cases we will be implementing. And these use cases could swap over different areas, from quality to R&D. And there are some main component pillars for these actions. It is the data, the technology, and the organization. What should we do with our data? Do we have it? If we have the data, are we generating data first of all? If we are generating this data, are we capturing this data and storing them, cleaning them, make it ready, curated data? Then are we using this data? All these questions need to be asked. Okay, I don't know why I'm pressing this multiple times. The organization. So we are talking about digital transformation, yeah? Meaning it's not about introducing new technology. We have to change ourselves. So things was working in the past for us will not work in the future, and that's why we need to change ourselves. So a big changes in our organization. Earlier AI things, I was sitting in the IT for 8 years, doing AI things, leading team there, and we have realized we are really isolated in our castle there, far away from the business. If someone from business needs anything from us, he has to write etiquette, and we are really doing our best to making his life not that easy. And then we realize, okay, nah, the aim of that is not to pretend to be busy. It's really to bring value. And then we say, okay, you know what? We bring AI to business, not the other way around. That's why we took the AI unit, the AI Competence Center, and located it next to the business as a competence center. And we are playing this bridge between the business and the technology, the IT. So we talk to the business, we understand the business, we feel their pain there, trying to communicate with them on their level of the business communication, then communicate with the IT to prepare the technology. And together we are building AI projects. But everything needs to be driven by strategy. Why? Because otherwise it's really randomness. Everyone is just running in random space, and it's like strategy, it's like electrons drifting aimlessly. With the strategy, they align and generate power. That's why every organization needs to have this North Star, these clear goals and measurable goals, and keep focusing on our goals. Of course, we can adapt them over the time. If there are any crises, the Russian-Ukrainian conflict now change everything, the power now price raised, we have to change it, yeah, adapt it, but we need to keep it and looking on it. As I said, different business models, but we try to stuck here in the middle, focusing on the cost, differentiation, leadership. And this is the model. I think it's already 20 years from Porter's generic strategy model. And back, I think you mentioned this study from the MIT that 95% of the adoption of generative AI failed. Yeah, because we are seeking to implement AI for the sake of AI without really a clear goal. AI, okay, let's bring a new chatbot. Why? What do we want to achieve? Retrieving data? Search engines, Lucene is already there for 30 years now. Google is there. You can use technology. There are the opening sources, a lot of their technologies for search engine. So it's not for retrieving information. It's way more than that. Good. Now I will try to present shortly, briefly, some use cases beyond chatbot, but still generative AI. When use, okay, sorry, I missed this one, so quickly, let me go quickly through this. So the autonomy of data-driven strategy should be consists of 3 pillars: technology, data, and people. Data without people, you have no timely decisions. People with technology without data, no informed decisions. And technology and data without people, useless systems. So I need to have system act quickly and to be informed or intelligent. This is the combination of these 3 pillars. So quickly here on so we started this again 2 years ago. We made this status quo analysis. Where are we? Also different pillars, different dimensions, North Star, use cases, organization, data, and technology. We make this a lot of interviews, questioning the business department. What do you want? What are you suffering from? How AI can support you? Or, by the way, it's not AI. Our question was, this new technology, the hype of a new technology, it could be a dashboard, by the way. How could this support you? And then at the same time, we analyze the market for companies like us, manufacturing company, 15,000 employee, and the benchmark, the top maturity here in Germany, what was it? And then we set for us a goal, 2 years goal, and with this North Star, and we achieve it. Good. Out of that, we start defining some use cases in the quality area. This is some of them in the quality area, low-hanging fruit, and then take each case. I hope I am, yeah. I was told that I have 30 minutes, right? Good, so I still have time. And then came up with this use cases. Every use case should be driven by the ROE. This is the golden rule here. Never make any investment before knowing in advance your return on it. Yeah. Good. I think this is the 6 V-Fragen question in Germany. Whenever you call the emergency, we're using the same thing, the same analogy at Rosenberger. Whenever we start a project, who will be involved? Who will make the decision? Who will be affected by that? Why? What is the goal? What are we doing there? Where should we apply it? It's in the automatic assembly process. It is in the quality inspection process. Where exactly? I need to know where I want to investigate. Which data source will be involved? Data points from the machines. And after all of that, waiting for results first, quickly make quick pilot, wait for the result, the feedback, and keep improving. And I always say here, fail quickly. Really, don't try to fix a broken machine. Fail quickly, throw it, because you will have plenty of other use cases to work on it. So don't waste your money on a losing horse. Good. Then this is coming to you. So the use cases we are working, and this is surprisingly, it's generative AI. So we build a model. It's called an anomaly detection model, reading data from the machine, reading data from the X-ray machines, and reading data from the camera, the inspection cameras, and making the decision if the product is okay or not. By doing that, we are not even inspecting the defects. We are linking the defects to the root cause because I am having the process data. So it's not about to say yeah or no, yes or no, defect or not. In German, we say NO or NEO. It's an Ordnung or not an Ordnung, nicht in Ordnung. But it's also linked to the root cause because you have the process data, what happened during the manufacturing process itself. And we published a paper on it. It's called Anomaly Detection in Smart Manufacturing. This is a generative model because we have an adversarial network. And this is surprisingly, it's AI, not a chat, generative AI is not a chatbot. It is really can be used at the shop floor for anomaly detection. The same base transformer with dual attention mechanism and adversarial training approach. Another case, typical AI, typical, I would say, agentic case. It's an FMEA, failure mode effect analysis, meaning if I have a complaint coming from the customer, I want to link it to my process and see my product and see which part, because when you are producing any product, you need to see it as a bill of material, different components assembled together to make the final part. And a defect could be caused by a specific part on this tree, or piece part. Then we took all the available data we have it in the Abyss, which is the software for the FMEA, QStudio for the customer complaint, ARB data, product data, everything. Extract them meaningfully, meaning it's not just extracting. I am extracting and building my knowledge base at the same time. Yeah. By also the help of an AI validator to tell me on the extraction phase that I am extracting the right data. So it's not just extract any data, go to your PDF, use Python PDF library, extract everything, put it in a chunks, and make the embeddings. This is the basic RAG model, but no, you can do way more than that. Building the knowledge graph consists of everything, the BOM, the processes, complaint, everything, and link them together in order to give this information or this data a kind of semantic meaning, meaningful meaning, yeah? And then having different chat or agents, everyone is tuned for a specific task, recommendation, gap analysis, complaint analysis, suggestions, and validation. And at the end, it's not a chatbot. It's a system with clicks. You can get suggestions, validation, gap analysis. FMEA, it is failure mode effective analysis, meaning if you have any failure, you know you need to link it to the root cause of it. So here we used really not the basic RAG system. So for you who is not familiar with the RAG, it's RAG. There's a good analogy for it. There are two ways to deal with LLM models. Asking them, getting an answers, basic thing. Then augmented your prompt with a context coming from the search engine at the end, typical search engine, and throw it with your prompt to the model. With that, you have more context in it. There is a fine tuning, taking a foundation model and train it with your own data if you have enough data for that. So you can see that a fine-tuning model, it's like a closed book exam, meaning a student go to there, just trained, learn what about the subject and trying to answer it. With RAG system, it's more open book exam. I can access to any book I have, but what's the challenge here? Which book? I have a pile of book, a big stack of books taken to meet the exam. Instead of answering the question, I will be wasting my time searching for the answer there. Yeah. So the best approach, there is now a new technology called Draft, which is tuning the model with augmented data or with retrieval data also. Meaning during the tuning, I am not tuning blindly. I am tuning the model with a context. Of course, fine-tuning the RAG system. Another enhancement could be prompt enrichment. So here, if you go here to this one, why it's not a chatbot? It's a system, because whenever I click on any button, I know the whole context. I know you are asking for this specific FMEA, for this specific complaint, for this specific piece part of the tree. So this is enrichment of the prompt itself. And the end user will not see that, will not realize that, because it's everything having in background. And I'm enriching my prompt and then sending it to the model. Semantic chunking. So take the chunking, it's really splitting the document, but okay, which size? What is the split point? If I have a table span on 2 pages, split the table, I lose everything. Even the extraction, I extract the table row by row, but I lose the column by column. This is the column relations. So then the best way to do that with the chunking, to build your knowledge graph first, and your knowledge graph will instruct you to make the chunking. But at the end, the chunk will be the base for the vector database. Yeah. Good. Of course, RAG graph. I impel or recommend everyone to try it, because this is giving you this meta information and kind of how is this working? It's really simple. You go to do this cosine similarity, whatever it's similarity you are working with it, retrieving some vectors. You think that your answer is there, and then every of these vector has a chunk. Every chunk has an ID. Every ID is linked to the graph in a node, and then you have different spots in the graph, and then by passing these spots, you build a context, this path of between these two entities, three different entities in the graph, representing the original chunks. Then I retrieve more chunks that has related to this context. Then send it to the LLM, the reasoning phase. Of course, with the whole when you are passing a graph, you are collecting context also here. This node is a part of this node, and then send everything to the model, and the model will giving you hopefully a better answer. And this is the new approach now. I think it's just 1 or 2 months ago. Raft, which is retrieval augmented fine-tuning model. Yeah. Good. So, good. As promised, I've saved 10 minutes for questions, in case anyone has a question. But I have, before I finish, I have some takeaways. Now we are, doesn't need to be in manufacturing, yeah? Everywhere in any industry. Things that earlier was impossible, but now we see that the new technology is really mature enough and unlocking a lot of potentials. Yeah, we just want to be ready for it. That's it. Another one is AI is learning from our experience, reflected in the data we are generated. All right. And then what is intelligence? Back to the root. Intelligence is mimicking human intelligence. Human intelligence are represented by the experience we are acquiring. Yeah. And this experience in digital world reflected in the data we are generated. The processes we are designing, the execution of the processes on the machines, any other piece of data. Yeah? So make sure to keep your data in a good shape in order to use it for your technology. AI will not replace human, definitely, but I can say it is advanced enough to accept it as an assistant for us. Yeah. By that, I'm done, and thank you for listening. And in case you have any question, please feel free to shoot. Daniel. Yeah, I know. Where is he? Yeah.
Did you set up the knowledge graph to be connected to the outer world, or is it just based on the knowledge you have within Rosenberger?
Yeah, now it's not the outer world because it's for us. We use this kind of In the reasoning phase, where is it? There is here gap analysis somewhere, I hope. That's it. What does gap analysis means? It is every day there is a handbook of every year, the VDER, I don't know if Deutschland Automotive, Deutsche Automotive Verband, whatever the association for automobile, they release a handbook of the new regulations. For instance, rear camera in America and the USA is safety relevant. In Germany, it's not yet safety relevant. But if it is safety relevant today, many of our processes need to be changes, yeah? And that's why this gap analysis here, we give this access to the outer world to go and fetch this kind of new changes on the data. But building the graph, we don't consider that. It's only Rosenberger.
So the ontology is built out of internal data.
Internal data.
So it's like a data extraction, and then you made up the triples out of your inside data, or
exactly. We have to start with the seedings.
With the seedings, okay.
Exactly, and then defining the entities. Okay. Let's far away from. Okay. Yeah, it's okay. Okay. Yeah, it's just we start with a small graph, swam it with a scroll through our data. There is something called Scrubber or whatever you call this, crawler. Oh my God, we are talking about real technique. Crawler is something goes to your database. If anyone is aware of process mining things, process discovery, there's a crawling mechanism, goes to your data and try to understand the linkage between all these data entity and data pieces in order to make your entities. Entities need to be meaningful, and then say, okay, but of course you start with seeding. Seeding means the basic entity, product, process, yeah.
But
but
okay. one last question. How did you come up with, because all your processes don't run in a single way.
Yeah.
There are a lot of ways that the processes run. So how did you achieve that the crawler did not get confused by not aligned processes?
Yeah, this is a good question. I don't know if you are aware of ZAG, zusätzliche Arbeitsgänge. This is what does that mean?
ZAG, yeah. One okay. Big problem in all manufacturing companies.
Any manufacturer, they have their blueprint of their process in real time. This is the process engineering department, the design product design. They sit together, they design the process, manufacturing process. In ideal world, suddenly something is not working. Then someone jump into the process and make an adjustment. This is an additional activity in order to bring the process back to the line. Yeah. Few years, months later, instead of having a lean process, you will have a spaghetti. Yeah. And not surprisingly, an additional activity here could be found different times because other people added cleaning, for instance. It's there. Because the process now is really a kind of ugly monster. No one wants to go and look at it and really say, okay, concise these, combine it together. There is a technique called process discovery. We have the blueprint on paper, okay, yeah. And then we have the process execution in the system, the logs.
Okay,
yeah?
You align the logs to the...
Exactly, and this is the crawler case. Yeah. Go from the timestamp, and for each activity, okay, now this was written in the system, this activity, this activity, this activity, then you got the start, end, and everything related to activity, and 1 minute over time. Yeah, so this is the way how to crawling during the process and building this ontology. Another question? Good. In case you have any other question, I think we have a round table, and we'll be pleased to answer your questions. Thank you.
Thank you very much.